All right, welcome back to Chapter 2, Section 3, Atomic Structure and Symbolism. Today, we're going to go over atomic symbolism, how to read atomic symbols, the letters, the numbers, and so on. What do they mean? So, every element is represented by a single symbol, and it may have more or less information in it. They always have a letter or a pair of numbers. That's an abbreviation of the name. For example, sodium, the 11th element, is Na. Iron is Fe. Oxygen is O. You'll have noticed that they don't always seem to match very well. Well, remember, English isn't the only language out there. So sodium is named after natrium, the Latin name for sodium. And iron, likewise, is the Latin ferrum. Sometimes it's a little bit easier to track down the origin, sometimes a little bit more difficult. Potassium comes actually from Arabic, alkali. In any event, that letter or pair of letters is the symbol of the element, the abbreviation of its name. It's either going to be a capital letter or a capital letter and a lowercase letter. You also get the atomic number Z. That will always be in the lower left-hand corner if it's present. It is the number of protons that element has. So, for example, sodium has 11 protons. Its atomic number is 11. Carbon has 6 protons. Its atomic number is 6. The thing is, every atom of an element will always have the same number of protons. So, the number of protons that the element has and the name of the element, those are identical, basically. Carbon is always atomic number 6. So, the atomic number is kind of redundant. It's useful information, but you don't need to write it down every single time you write down the name of the element. The same way, you don't always write down Mercury, the first planet. Mercury is the closest planet to the Sun, so writing it down as Mercury, the first planet, every single time would be redundant. You wouldn't do that. Next up, we have the mass number, A. It represents the total number of protons and neutrons contained in the nucleus. So, if your isotope has 6 protons and 6 neutrons, then the mass number would be 12. If it has 6 protons and 8 neutrons, then the mass number would be 14. Now, the mass number changes in a way that the atomic number doesn't, because you have different isotopes of each element. But again, we don't usually include this, because the isotopes don't really have strongly different chemical behaviors. Again, to reiterate, the different isotopes will have slightly different behaviors in some ways for different reasons, but it's not usually a significant difference and not one we focus on all that much. We care about the averages of all the isotopes far more than we care about individual isotopes, so we don't often include the mass number A. Now, something important to note. The mass number is not the same as the mass of the element. The mass is the measure of the amount of matter in the object. Okay? It's the actual mass of the atom. The mass number is just a counting. It's a count of the total number of protons and neutrons, P plus N0. So those are two different numbers. The names can be kind of confusing, but you're going to have to keep them separate. Keep them apart in your head. Mass is not mass number. Finally, we have Q, the charge of the atom. This is always included, even when it looks like it's not. So Q tells you how many electrons you've gained or lost. Okay? So technically, if you want to think about it in terms of math, it's the number of protons minus the number of electrons. A neutral atom will have the same number of protons and electrons. P minus E will be 0. If you've gained electrons, you'll have more electrons than protons. You'll have the negative charge. If you have lost electrons, you'll have fewer electrons than protons. Then your charge will be a positive number. That's one way to think about it. The charge tells you how many electrons you've gained or lost. And charge has a huge impact on the chemistry of the atom, so it's always included. The way we might appear not to include it is if the charge is neutral. We don't write down a 0 to indicate a neutral charge, we just leave it blank. So here are some examples. I've included all the numbers, even though normally we don't. Okay. So here on the left we have sodium. Sodium is the 11th element, so it has 11 protons, and so its atomic number 11 is written in the lower left. And then on the upper left we have the mass number. This particular isotope of sodium has 11 protons and 11 neutrons, giving it a total mass number of 22. And then in the upper right, we have the charge. You can write this in different ways. You can write plus, or 1 plus, or plus 1. It doesn't make a huge difference. It's written in various ways. So long as you indicate what the total charge is, you'll be okay. In this case, sodium has lost 1 electron. So it has a charge of positive 1. It only has 10 electrons. Then here in the middle, toward the bottom, we have an oxygen atom. Every atom of oxygen has 8 protons, hence the atomic number 8. This particular isotope, this particular atom, has 8 protons and 8 neutrons, giving it an atomic mass number of 16. And this particular atom of oxygen is an ion. It's gained 2 electrons, giving it a -2 charge. And then over on the right-hand side, we have an atom of uranium. Every atom of uranium has 92 protons, an atomic number of 92. This particular isotope of uranium is uranium-238, meaning it has 146 neutrons. 238 minus 92 is 146. And as an ion, this particular atom of uranium has lost 4 electrons, giving it a +4 charge. It has 88 total electrons. So those are atomic symbols and how you read them. Keep in mind that the atomic number and the mass number are often, in fact usually, not included, but the charge always is. See you next time.